Welcome to the DIY Honda Garage channel. The DTC P0A11 refers to a malfunction within the DC-DC converter activation circuit. This error indicates that the powertrain control module, or PCM, is unable to receive a boost demand notification from the DC-DC converter. The DC-DC converter is responsible for converting high-voltage DC power to a lower voltage to charge the vehicle's auxiliary battery, which is vital for various electronic components and systems to operate. This malfunction may result in a failure to supply the necessary power for these components, disrupting normal vehicle operation. The PCM is the central computer that manages the engine and transmission systems, ensuring efficient performance. When the PCM detects abnormal conditions, it logs a diagnostic trouble code to assist technicians in diagnosing and repairing the issue. The identification of the DTC is the first step in the troubleshooting process to restore proper functionality to the vehicle. In investigating the DTC P0A11 error, it's crucial to understand the specific components involved. The powertrain control module, or PCM, is instrumental in the vehicle as it interprets signals from various sensors to manage engine operations. The PCM is typically located near the engine compartment. The DC-DC converter is a vital component that takes high-voltage power from the vehicle's battery and converts it to a lower voltage for auxiliary battery charging. Often located near the battery assembly or integrated within the power distribution setup. An issue with the DC-STS circuit, which transmits signals regarding the DC-DC converter's operational status, can create a failure in communication between the PCM and the DC-DC converter. These components need to work in harmony for optimal vehicle performance. If any signal or component fails, the PCM will flag this error by logging DTC P0A11, indicating a malfunction in the activation circuit. Several issues could lead to the DTC P0A11 being triggered. One potential cause is an open circuit within the DC-STS, or the DC-DC status signal circuit, which could disrupt communication between the DC-DC converter and the PCM, leading to a malfunction. A short circuit in the same line could also create faulty signals, making the PCM believe that there's an issue when there might not be. Additionally, the DC-DC converter itself could be faulty, leading to an inability to provide the necessary boost demand to the PCM. Lastly, if the PCM is malfunctioning, it may fail to process information correctly, potentially misinterpreting data from the DC-DC converter. Each of these issues requires careful inspection and diagnostic steps to identify and rectify effectively. The symptoms associated with DTC P0A11 can manifest in various ways that impact vehicle operation. One of the primary symptoms is engine performance issues, which may range from reduced power output to stalling or erratic running behaviors. As the DC-DC converter fails to provide adequate power to the auxiliary systems, electrical system failures may occur, affecting components such as lights, infotainment systems, or climate controls. Additionally, drivers may notice warning lights illuminated on the dashboard, specifically the check engine light or other indicators, alerting the driver to possible faults within the vehicle's systems. Addressing these symptoms promptly is crucial to avoid further complications or safety hazards while driving. The first step in troubleshooting the P0A11 DTC is performing a test drive to assess the behavior of the vehicle under the automatic idle-stop system conditions. During this test drive, the vehicle is driven as per normal operations until the engine enters idle-stop mode, which saves fuel. After achieving the auto idle-stop condition, the technician must then engage the stop function, ensuring the engine shuts off as intended. This step is pivotal as it helps establish whether the DC-DC converter and PCM can communicate accurately in real-world driving scenarios. Monitoring vehicle behavior during this process can reveal inconsistencies that suggest where the fault may lie, leading to more targeted investigations. The second troubleshooting step involves inspecting the DC-STS circuit for any potential wire issues. Specifically, technicians should conduct an open wire inspection to confirm the integrity of the signal circuit related to the DC-DC converter. The goal here is to determine whether there are any breaks or interruptions in the circuit, which would hinder signal transmission to and from the PCM. An open circuit may indicate physical damage or disconnection, leading to the DTC being logged. To ensure accuracy, technicians should measure the resistance in the circuit, with values of less than 1 ohm indicating a good connection. If an open wire is found, repair or replacement of affected segments will be required to restore proper functionality. Following the inspection of the DC-STS circuit, the next step is to verify whether the DC-STS has shorted to power. This condition could severely affect the PCM's ability to receive the necessary signals from the DC-DC converter. To perform this test, technicians need to switch the ignition to on and check for any short circuit conditions. If the circuit is verified as not being shorted, it confirms that the signal circuit is functioning within normal parameters. Conversely, if a short is discovered, it would indicate a need for immediate repairs or replacements of the affected components to prevent further issues in the vehicle's electrical system. The next step in the troubleshooting process is to inspect the DC-DC converter itself. Given that direct testing is not feasible, a practical approach is to replace the suspected faulty converter with a known good unit. This swap allows technicians to observe if the vehicle's performance changes and if the DTC persists. Installing a working DC-DC converter can help establish whether the original converter was at fault. If the symptoms persist after this replacement, it implies that the issue may lie with other related components or wiring rather than the DC-DC converter itself. Conversely, if the DTC clears, it confirms that the original converter is indeed the source of the malfunction. The fifth troubleshooting step involves inspecting the powertrain control module, or PCM, especially if previous tests indicate that other components are operating normally. This step is crucial because a malfunctioning PCM can lead to a cascade of issues mimicking other faults. If the components associated with DTC P0A11 are verified to be in good condition, then the PCM may be the culprit. Technicians can conduct further diagnostic tests to evaluate the internal operations of the PCM and determine if it's responsible for not processing information accurately or managing communications with the DC-DC converter. If confirmed faulty, the PCM may need to be replaced to restore proper functionality to the vehicle. Once all potential issues associated with the DTC P0A11 have been addressed, the final step is to verify all repairs have been successful. This begins with rechecking all electrical connections related to the DC-DC converter and the PCM to ensure they are secure and functional. Any loose or corroded connections could result in similar issues persisting. After visually inspecting the components, technicians should clear any logged DTCs from the vehicle's computer and proceed to test drive the vehicle under normal operating conditions. Observing the vehicle's performance post-repair is crucial to confirm that the original DTC has not reappeared. A successful test drive without any errors will indicate that the issue has been resolved effectively. Preventive maintenance plays a pivotal role in avoiding future DTC P0A11 occurrences. Regular inspections of the DC-DC converter and its associated circuits are key to identifying problems before they evolve into major faults. Technicians should recommend checking electrical connections for corrosion or damage during routine service sessions, as these can significantly impact the communication between the PCM and other critical components. Educating vehicle owners about the importance of maintaining proper voltage levels and ensuring all components are functioning correctly will promote a longer lifespan for the vehicle's operating systems. Regular maintenance also reduces the chance of unexpected breakdowns and losses in performance, ensuring a smoother driving experience. In conclusion, DTC P0A11 indicates a malfunction in the DC-DC converter activation circuit, which requires careful investigation into several components, including the PCM, DC-DC converter, and DC-STS circuit. Understanding the roles of each of these components is essential for effective troubleshooting. Following a systematic approach to diagnostics, from observing symptoms to executing thorough inspections and repairs, is crucial in resolving the issue. Preventive maintenance can play a significant role in decreasing the likelihood of such errors occurring in the future. With proper attention to these factors, technicians can ensure that the vehicle operates effectively and reliably, enhancing the overall user experience. Please like and subscribe to the channel. See you next time.